out the maximum baud rate or minimum baud rate we can have. So for minimum baud rate, so we know the formula, right? So formula is FCY over 16 UX BRG plus 1, right? So that's the formula. Here, the UX BRG, sorry, this is not plus 1. So the UX BRG is a 16-bit register. So you can, the maximum value to have minimum baud rate, this denominator have to be the maximum, right? So, and the maximum value you can put it here is, you know, obviously if it is a 16-bit, so it's going to be 65,535. Okay, so then for minimum, the formula becomes, you know, 16 times 6,500, 5,036. Okay, so that's it. Oops. Yeah, so that's the minimum baud rate formula. And for the maximum baud rate, again using the same formula, FCY over 16 times UX BRG plus 1. So, you know, the minimum you can have here is going to be obviously 0, right? So minimum. To make the baud rate maximum, you have to have the smallest denominator, and the smallest UX BRG value is going to be 0, obviously. So from there, the formula becomes FCY, you know, 16 times 0 plus 1 is going to be 1, so it's going to be this. So this is the, you know, the maximum baud rate you can have. Okay, and you know, that's this two formula that helps you to figure out like minimum and maximum baud rates. In when we talked about the registers in UX mode control register for UART, there was 1 bit BRGH bit. Let's talk about that. Oops. So BRGH bit in UX mode control register. Again, we can just very quickly go there and see it. So yeah, so that's not the one, this one. So BRGH, again, this one is basically a high baud rate select bit. Okay, so if you select the 1, this is gonna be the high speed. It's gonna be in the high speed mode. If you set it to 0, then it's gonna be low speed mode. So what changes if well, let me move to the next page. Again, basically this high baud rate selection bit. Okay, so let's move on. So if we select BRGH, if we set it to 1, then baud rate formula is changing. Like if we select the high baud rate option, then baud rate formula becomes a little bit different. So it becomes FCY over 4 times UX BRG plus 1. Obviously in the slow one it was 16, obviously that makes it slower, and from there the same formula, UX BRG if you can calculate UXBRG by FCY over 4 times baud rate minus 1. Okay. Again, these two formulas are important. Okay, so that's good. So basically, BRGH, again, these formulas are true when BRGH is 1, and when BRGH is 0, these formulas needs to be applied. Okay, for low baud rate option BRGH 0, these formulas needs to be used, and for BRGH equal to 1, these formulas has to be used. Again, these are also, you can see them in the data sheet too. I don't have the data sheet, like the main data sheet, open, but let's see if these formulas are here too. Maybe, I'm not sure, like it's in the main data. Yeah, here. So yeah, baud rate formula, if BRGH is 0, then you use these formulas, and if your baud rate BRGH is 1, then you use these formulas. So yeah, and let's moving on. So let's talk about few limitations of UART. Okay, so and then we will end our discussion here. Limitations of UART. Well, again, one limitation is, again, both sides must agree on the baud rate ahead of time, right? Baud rate ahead of time. Okay, so that's one limitation. Yeah, so another limitation is data inefficiency, data transmission. Right, so like basically you need to, depending on what mode you are in, but let's say the way we did like in this lecture, we transmitted 7-bit, then we had start bit, we had stop bit, and we had parity bit, right? So you need 10 bits to transmit 7-bit, right? So it's like so out of 10-bit, 7-bit data, right? So the efficiency is then, you know, like so it's 70% efficiency, the 70% data transmission. Okay, so yeah, so another limitation is another limitation here is only suited to communication between two devices. So only suited to communications between two devices. So so this is important because, again, so you cannot scale it, you know, like you can with the I2C and, you know, SPI, So you can communicate, like many devices can communicate with each other. So like they are kind of a little bit different, but they can. So with this, only two devices can communicate with each other. So not scalable. So another limitation is, I mean, it might seem very fast, like you can have, millions of bits per second. Like if you let's say if you select, if you go to the maximum baud rate, like the formula here. So if you calculate like 16, that for our microcontroller, it's going to be 16 million over like a 16 megahertz, which is 16 million over 16. So it's going to be 1 million per second. It might sound very fast, right? I mean, like, so it's fast, but compared to other ones, it's really slow, like SPI and I2C. Like if you think about having a megabit per second kind of stuff, so this is kind of slow compared to them. Again, slow baud rate. Again, depending on your need, this might be perfectly fine, but compared to other protocols, the serial communication protocols we will discuss, this is a little bit slow. So that's all I have for this lecture, and I'll put the video, and also I'll put this PDF, this document as PDF. So make sure you watch. If you need, you can go back and watch the different parts again. Thank you for listening. Hopefully this was helpful, and we will have discussion later, next week, about the same content.